So I'm getting started right now. So welcome everybody to another class session. This will be the third class. Okay, just give me one moment. All right, so I welcome everybody to today's class, and then I hope that you all had a great time the last class, even though it seems technical for people that are just getting into this language. But I'm going to do a recap myself for the things we talked about in the last class. Before I do that, I would like you all to contribute. So if you've got one or two things to say concerning what you learned in the last class or your feedback, can we get that? So a show around and I'll allow you unmute your mic. So anybody who got anything to say concerning the last class? I'd like a recap. Anybody? Okay, I don't think anybody's raising his hand, so let me just do myself. So in the last class, we introduced also the Python programming language, right? And right out of the gate, we started by saying Python is an interpreter, not a compiler. And that implies that Python reads your code line by line. So if I start off by saying print hello world, and the next line I say print end of code, it's going to do this just the way I wrote it. Okay, so some little tips about Jupyter Notebook or using Jupyter Notebook is that instead of coming here to click on run, you can just press shift and enter, and then it runs and take you to the next cell. So as you can see, there's just one cell right now, but of course, going forward, I need to write another code and I need to open another cell. Doing it manually, what I would have done is press run, okay, and then it opens another one. But rather than doing that, I can just, press shift and enter key on my keyboard, and then it runs that code and then opens a new cell immediately. So I think this is more efficient than coming to click on run here. Okay, so what I was trying to point out is that things are done line by line. As you can see, it printed hello world first, and then it printed the end of the code. Okay, so that was the first thing we said, and we also said that indentation matters. So if you attempt to put some indentation here for some reason, it's not going to run, right? So it's going to give me an error because it's not expecting any indentation here. But we said that indentation between text doesn't really matter. So if I come here and then put some spaces for whatever reason, I don't know, and I run my code, it's still going to run the same way. Okay, although this is not the best practice. The best practice is always to leave no space between the function and then the arguments. Okay, so this is the function, print is a function. Okay, when you're calling a function, you use parentheses. So if you want to call a function, the name of the function, say for instance, print is a function, and then I open and close the parentheses. So inside this parentheses, I take my arguments. They call it arguments. Okay, so in the print statement, the first argument you take is just the object you want to print. So the object I want to print in this case was hello world, and that's why I typed hello world. In the second case, I wanted to print end of code, and that's why I typed end of code. So anything I want to print is what I'll put first here, right? Okay, going forward, I'll also explain some of the other arguments you can define in this print function, but I don't want to make things too complicated right now, so I wouldn't talk about them just yet. Yeah, so that's that. And then we also, okay, so some people are waiting. Let me admit all. Okay. All right, so we also spoke about variables, and variables are very important things in Python because they are like pointers to objects. Okay, so you store objects in a variable. I use the scenario like you have a book and you're keeping your book in a bookshelf. Okay, so you can see variables as a bookshelf. Although that's a simplified explanation. If you're looking at the concepts in an object-oriented manner, which I don't want to get to just yet, you wouldn't call the variable the bookshelf. Rather, you call the variable a sticker to show that these are books. Okay, so well, you can see variables like that. So you may not see variables as a container, although yes, they are containers to store some things. You can see them as labels to that container. Okay, so we'll go further. And the reason why we actually do that, let me just say it, is because if, for instance, I have a variable A and I called it Olaye, because that's the name I'm seeing right now. Okay, and I called it Olaye, and then I want to check where this variable is stored. What I use is the ID function. Okay, so I use the ID function to check where this object is stored. Okay, I said object rather than variable. And I really don't want to complicate things, but let me just say right now that everything in Python is an object. So I may use objects, variables interchangeably. That's because basically everything is an object. And I'm going to get to that when we get into object-oriented programming, which is a vital concept in any programming language whatsoever. But I don't want to get things, I don't want to go so complicated just yet. So I just have to say that right now, that everything in Python is an object. So a variable is an object. So anyway, so I'm going to use the ID function, like I said, and then I've written the name of the ID function. But to call it, I have to open and close the parentheses, like I've explained earlier. So I open parentheses and automatically it closes it. So this ID column is just used to check the location, okay, where this variable is stored in my computer, okay, or where this object is stored in my computer. I'll rather say it that way, okay? So let me check where this object is stored. So I pass in argument A, which I've defined up. So if I do that, you realize that the object is stored somewhere here in my computer. This is like a location, right? Or a memory in my computer. Okay, well, if I come right now and then I call another name, this time let me call it Glory, because that's what I'm seeing on my screen. And let me print now, because, okay, let me say this. Automatically, right, Jupyter Notebook prints the last line you write. If it's a line that can be printed, Jupyter Notebook prints it, okay, automatically. But if you're working with other IDE, you have to explicitly type print for it to be printed on your screen. Okay, so I needed to say that. So so I print again B. Okay, so I print B, the ID of B. So I want to check the memory location of B. And then if I do that, you see that it's quite different. Okay, so this was stored somewhere here, and this was stored somewhere here. And that's because these are two different objects. Okay, they are two different objects. But if by any chance I change this guy, okay, I change this guy to the same, you can see that there are different variables, but the object itself are the same. Okay, if I now check the ID, notice what do you notice? Now where they are stored is the same. They are stored in the same place. That's why I said variables can be seen as stickers or as labels, because although they are different variables, they are the same object. Okay, so this was just a scenario to tell you that variables are not really, you can't call them the bookshelf itself. You can just call them stickers to show what's inside the bookshelf. Okay, so yeah, I just wanted to say that was not part of what I wanted to say. Okay, so we talked about variables, and I said they are just way of storing objects in Python. Okay, so next also we talk about the various data types we have in Python. Okay, we mentioned the integers, and those are just whole numbers. Okay, so you have something like, let's say a number is equals to 2. Okay, if we check the type, we use the type function to check what kind of data type they are. So if I check type of number, it's going to tell me this is an integer. Okay. We also said you had floats. Okay, let us call it variable, so I don't have to be changing up and down. Okay, so if I put like 2.43 for instance, and I check the type. Oh, sorry, I was wondering what happened. Now look at what happened. Python, because the first one was number, okay, and I still use type of number, it was still giving me data type of that number, right? That's because that number has been stored somewhere already in my program, even though it's not here anymore. And that's one thing about Jupyter Notebook. In other, I think VS Code, once you remove that, it will tell me number not defined. It will give me a name error. Okay, but in Jupyter Notebook, you have stored it somewhere, and it's still going to print number even if I have removed number from here. So the mistake I made was to, of course, change this back to variable. So now it should give me a float, and I can see it gives me a float. So we also said you had strings, okay, and strings just involve letters. Okay, that's how I'll put it, letters. And then you define strings using apostrophe. Okay, you define strings using apostrophe. You can use single apostrophe, you can use double, whatever one works. Okay, so in fact, you can put a number, for instance. If I put number like this, all right, because I have opened this apostrophe, it's going to see this as a string. So if I print it out, you can see it gives me str, which is a string. But you can also use letter, so you can use something like I'm seeing Felix screen, so I'm printing Felix, and let's see Felix is he has the data type of a string. So what the last thing we mentioned was a non type. I think you use non often because when you start doing null or missing values, you would use non a lot. So if I print that, it tells me that's a non type variable. Okay. Then we went ahead to also talk about data type or data structures. And data structures are just what you use to, to contain more than maybe one object. Okay. So for instance, if I want to store the names of people in a class, I can't start calling the names one after the other. So what I use lists. Okay. So I said the three major data structures. We have lists. Okay, we have dictionaries, we have sets. Okay, but you mostly use lists and dictionaries. Okay, so this is a list, for instance. So list can take more than one element or more than one object. So they are separated with commas. So first, to create a list, I told you that you have to open a square bracket like this. All right, and then once you open the square bracket, you can now pass in the number of elements you want in your list, or however you want it to be in your list. So let me see, I just want to create a list of people in this class, for instance. Okay, so I take my first name, because name has to be a string. I must open an apostrophe like this. Okay, if I pass my name like this, Python will see this as a variable. Okay, Python will see Alabi right now as a variable, even though Alabi contains letters. Okay, so if this must work, it means that I have to define Alabi to be somewhere. Maybe before I wrote that, I must say maybe Alabi is equals to maybe let me not say 2. Okay, so if I run this right now, it won't give me an error because I've defined Alabi. Okay, but if I had done this, all right, it will give me an error because first, Python doesn't know what Alabi is. It's seen Alabi for the first time, right? So rather than doing this, I can just encapsulate this in apostrophe. So this way now it sees Alabi as a string, okay, and not as a variable. Okay. Okay, so I also want to put other names there. So Alabi is waiting, actually, that's how I'm seeing his name. Okay, so I've admitted Alabi. So I'll put Taiwo because Taiwo is also waiting. And then, okay, I'm seeing Adidamola. So let's put Adidamola. Okay. I put Adidayo as well. Okay. Okay, so let me just leave these names. Okay. I think these are good. Okay, so what I've just created right now is a list, and I store that list in a variable called names. So if I want to print all the names in my list, I just call names, of course, and then it prints that for me, as you can see. All right. But if, for instance, I just care about the first name in my list or any one element in my list, what I have to do is what we call indexing. Okay. And in indexing, what you do is that you call that list first off. Well, you know that if I print it like this, it's going to print everything. So if I want to print any specific one, you have to index, I have to show the index of that list. So I have to show the where exactly that element is. So if, for instance, I want to print the first element, this is the first position. But recall I told you that Python starts to count from 0. Okay, so it starts to count here from 0. So this is 0, Let me take this out. Okay, this is where am I? Okay, this is 0, this is 1, this is 2, and this is 3. Okay, so this is the way Python indexes. So if I come here and say I want to just print the first one, I just put index of 0. And then if I run this, it's going to print Alabi straight away. Okay, so if I care about starting from the end, okay, and I want to print say the last number. I told you that when you're starting from the end, Python starts from -1. Okay, and so if I want to print that, what I do is I start from -1, -2, -3, I was correct. -1, -2, -3, -4. So if I want to print Alabi again, but assuming I'm starting from the end, what I will do is -4. Okay. Okay. So if I run that, -1. It's telling me out of range. Is it -3? Just give a moment. -1, -2, -3. Oh, guys, I made a mistake here. You guys didn't tell me. I was wondering what was going on. Okay, what happened was this, right? I opened my parentheses. I didn't close it until I got here. So Python is seeing Taiwo Adedamola as one element. Okay, that's what happened. And that's why it was telling me out of range, because I was wondering what exactly was going on. Okay, so because I didn't close my parentheses until here, Python saw this thing here as just one element. Okay, so if I'm to fix that, I'll just come here and put 1, and then come here and open another one. Okay. Okay, so I think that should be good now. So if I run this, it gives me Adedamola as one element, and so I can do my -4 again, and then it prints Alabi. Okay, so that's the idea of indexing, and I hope everybody is following. This is just a recap of what we did in the last class. Okay, and I also mentioned that there may be situations where you want to print from one element to another element. Okay, and so to do that, you use what we call slicing. Okay, and in slicing, what you just do is that you indicate your starting and ending elements. Okay, so for instance, I want to print from Alabi to Adedamola. My starting index will be 0, right? So I start with 0. And then I separate my starting and ending with a colon. Okay, so now the next thing is to put my ending index. If I'm stopping at Adedamola, my ending index here is is 2. Okay, because of course 0, 1, 2. So if I run this, it's going to actually stop at Taiwo. Remember, I said, okay, thank you, Armstrong, for pointing that out. Now, remember, I said when it comes to range, Python takes off the last element. Okay, so if I run this right now, it's going to take off this last element and stop at Taiwo. Okay, so if I run this right now, you can see stop at Taiwo. But if I put 3, okay, it now stops at Adedamola. So this is the syntax of Python. I think it's important for you all to know that. Okay, so we went on to talk about operators in Python, because most of the time we're dealing with a lot of operations, and then of course, the basic ones. I do, for instance, one. Okay, this is the problem I have with this system. Okay, so 1 plus 2 or 2 plus 2. If I run that, it's going to give me 4. Okay, if I do 2 minus 2, it's going to give me 0. Okay, I can also do division. 2 divided by 4. It's going to give me 0.5. I can do, what else? Multiplication. 2 multiplied by 4. It's going to give me 8. So I can do all of this stuff. All right. But there are 2 other operations I want to introduce you to, and that's floor. And then when you're doing floor, what it does is that when it checks, it prints out the remainder of the division. So this is like a normal division. So you can also do floor division. For instance, you want to do 8 divided by 3. Now, 8 divided by 3 is what? A normal D. Right? That would be 2. That would be 2 remainder 2. Okay. But if I do the floor, it's going to print just the remainder. Okay. So it's going to print just the remainder, and you can see it prints 2. Okay, maybe I should make it 10. So it to make more sense. So if I do normally 10 divided by 3 is 3 remainder 1. Okay, so if I do this, it's going to print 3. Now, if I care about the quotient, if I care about this answer, what I do is I use the percentage sign. Okay, so this is, they call it modulus. So this one just prints out the whole number involved. Okay, so if I do that, it's going to print 1. Okay, let me know if I'm making sense. Let me know if you've been following me. Oh, okay, great. Great. So I think then we also spoke about, of course, exponential. So if you want to do like 2 raised to power 5, you can do 2 raised to power will be multiplication sign twice. So I do multiply by maybe 5, and then that gives me the answer. Now recall that this is happening because I am using Jupyter Notebook. Or in normal day, I should put print statements in all of these things. If I go to VS Code and type this, it won't run. It won't print anything. It will run, but it won't print anything out. It won't give you any feedback because I didn't put a print statement. A print statement is just what you use to tell the Python to, show me what's going on. Show me the answer to this, right? Alaye said something. Floor gives the answer and percentage. Yeah, gives remainder. Yeah, floor gives answer, gives, yeah. Is that what I said? Oh, I think I mixed up something. Well, thanks for that. Okay, yeah, so actually this gives the whole number, right? Okay, yeah. This gives the whole number, this gives the remainder. Okay, this is floor, this is modulus. Yeah. So I think we are good with that, right? Okay, so what else would we talk about? Yeah, okay, so now that was for list. And we also mentioned that you can perform different functions to a list. Okay, so a list has different functions, or you call some methods. Okay, so for instance, you want to add an element to a list, use the append function, append method, not function. Okay, so for instance, I had my list already. My list was names, of course, so names. Now, if I want to add one more name to this list, okay, I need to add a name to the list. I found out that I add a newcomer, and I need to add his name to my register. I use the append function, okay? So the append function, you can check it out. It takes the objects. So it append object to the end of the list. Append means add, okay? So it adds that object to the end of the list. So now my object will just be a string of the last name I want to put. So let me say I want to put Mitsu. Yeah. So if I put Mitsu right now, I'm sorry, I spelled your name wrongly. It will change my list and add Mitsu to this. So what I can do now is to print names. So if I print names, you can see that Mitsu is there. Okay. I can also remove that name back, and I use the pop method. So the pop just remove the last name in the list. Okay. So if I write the names back, you can see Mitsu is gone. Okay, so you have many other methods you can use, and I told you one thing you can do is to put the dir function, and if you pass the data type, for instance, it prints out the different methods you can use. All these for now, don't bother about them because they call them they're special methods. But for this one, you can append. These are the ones you care about, right? You can append, you can clear, you can copy, you can count, you can extend. You can index, insert, pop, remove, reverse, sort. So all these you can do to this object, which is a list. Okay. Yeah. So that's that. Lastly, let me just talk about dictionaries because they are so very key when it comes to data structures. Okay. So dictionaries is a special data structure that has to do with you having a key and a value. Okay, so just the way you have dictionaries, English dictionary, where you have a name or a word and its meaning. In the same way, in the dictionary in Python, you have a key, all right? And a key is just what you use to find the value. So you have a key, and then you have a value. And then I said in Python, you define dictionary with curly braces. Okay, so you open a curly braces like this. It means, wow, I'm going to define a dictionary. So someone is waiting. I can't see anybody waiting. Okay, people are waiting after having them. All right, so you have to create a dictionary. Of course, you use a curly braces like this. You open and close it. Now, the first thing is to define a key. Okay, let me just call this dictionary A. Okay. Okay, so let's say I want to have a dictionary that store the name, the email, and the phone number of people. Okay. All right. So the first thing I will store is what? The name. So I'm going to store the name like so. Okay. But I made a mistake here. I didn't put this guy in apostrophe, and so he's going to assume their name is a variable, which of course is not. So I should have put them in apostrophe like this. Okay, that means it's a string. Okay. That's my okay, yeah. So I split key and value with this column, as you can see here. Okay, so the next thing now is to define my value. Now I can just define one name like this, David. Right? This will work fine. If I let me go on like this. Okay, so I've defined one key and one value. Okay, so now let me go on. The next thing is to define email. So define email like this, and then that's my key. Of course, my value will be let me just say david@gmail.com. Okay, let me also add an age here because that's a fantastic thing to put. So age, of course, would be an integer. It can't be a string. So in an integer, let me just say David. So David is 12 years old. What else can I put? Okay, I think it's good that way. So I think it's good that way. So I've defined a dictionary to store this information: name, email, and age. So if I run this right now, it has been stored. This dictionary has been stored in the variable dict A. Now, if for instance I want to access David's, I want to access the name, or right, I want to know the name in my dictionary. What I do is that just the way I do indexing in lists, I also index this guy. Okay, so of course, how do you do indexing in lists? You open a square bracket, right? You open, okay, you don't open indexing. This is slicing, but yeah, it's almost the same idea. So you open a square bracket. Okay, so I open a square bracket like this, and then I pass the key. Okay, so if I want to check the name, for instance, I pass this key. So I come here and I paste it like so. And if I try to check this out, it tells me, oh, this key, or the value to this key is David. So dictionary is just a way of using something to access another thing. Okay, but now let's assume I have more than one student. David is not the only student, right? So what I can do is that I can put this in a list form. So I can put them in square brackets. I can add more names right now. So I have David. I have Adedamola because I'm just in Adedamola on my screen. So I'm going to put his name again. I have Adedayo. Adedayo. Okay, and then let me look for a shorter name. Okay, Toby. I don't know. I like Toby. Okay, so yeah, I have that. And then now let me update their email. So I have adedamola@gmail.com. Okay, let me take this out. It's confusing me. Okay, so yeah. Okay, now interestingly, I didn't pass this as a list, so that's a big mistake. So I should pass this as a list, not a string anymore. Okay, because I'm taking more than one email, so I pass it as a list. So I go on. adedayo@gmail.com, and then lastly I do Toby@gmail.com. Okay, so for their age, I have 32. Sorry, I have 10. I have 91. Okay, so these are their ages. So if I come right now, let me run this to store it back. Don't make any mistake on my syntax. Oh dear, I didn't pass this as a list. Why am I making this? So I passed it as a list. Okay, so if I run this, it runs successfully, and I come here and check for my names. You can see it prints these names. Now, if I care about, again, the first name, what I can do is I can index these lists just by doing indexing of a list. So I have taken this, and this gives me my list of names. If I now care about this first name, David, what I can do is again to index this by putting another square bracket and passing its position, which is 0. So if I run this, it gives me David. Now I can also do this for email, it gives me that. Okay, if I care about the email of everybody, it gives me that as a list. Okay, so you can do a lot of stuff with dictionaries. In fact, you can create tables, which we'll call data frame when we get into using of Pandas library. Okay, so you can create your tables. Maybe you want to create a data set yourself from dictionaries. All right, you can create fantastic tables and you can work with tables, right, with dictionaries. So they are very important stuff when it comes to data science, and I think it's important for us to dwell on this for a while. You also have sets. You won't use set often. The idea of sets is just to remove duplicates. Okay, it's also a collection of data. So let's say in my name, for instance, I have 2 Adidamola. If I pass it as a set, it's going to take it out. It's going to take out 1 Adidamola and just give me 1. That's the idea of a set. And then you define sets with curly braces. Yeah, but in the case of dictionary where you have key and values, in sets you just have values. So these are my values. Copy it, paste it. Okay, and then so you can see set as lists, but list without any duplicates. Okay, so if I run my set1, if I run set1 like so, you're going to see it gives me the same thing. Just where lists are, anything you can do with a list, you can do with the sets. But if for any reason I add 2 Tobis and then I create another Toby right now, and then I run the sets, you can see that still it just gives me 1 Toby. So the idea of sets is that it takes out what duplicates. So anywhere you see an element append twice, you just take it out. But if this was a list, for instance, so let me change this to a list. Turn curly braces to square brackets, like so. If I run this, you can see that my Toby appears twice. You can see. I think these guys are going to take us off in just 1 minute. But it's important to do all of this recap. So in today's class, I'm going to talk about control flow. And I think it's also a very important concept in Python because it kind of guides how your program runs. So the idea of control flow is that do this only if a particular statement is met or a particular condition is met. So the first control flow statement we're talking about is the if else statement. So I think these guys are okay. I guess it's making sense, right? Okay, great. Now the last control flow we are going to talk about is while loops. Okay, while loops they operate like for loops, but while loops don't iterate or they don't loop over iterators. Okay, so for while loop basically run automatically. It runs continuously until a condition is met. Okay, so in for loops, what you do is that you loop over a list, but in while loop, we run the thing continuously until a loop is met, until a condition, is met. So now, let's say you want to do the exact same thing we did here. We want to create a list from 0 to 14. Okay, the first thing is to first create an initial number. So you can just say I. Okay, we call I 0. Of course, you create your empty list too because so let me just say call it list 2. Okay, create that empty list. Okay, so to create out my while loop, I'll say while I is less than 10. Oh, okay, I did 15, so let me use 15. Okay, so while I is less than 15, what I can do is my list 2, list 2 dot append I. It's just the same thing here, right? The same thing here. Okay, so the next thing is if I run this code for any reason, it would be an infinite loop because I will continuously be 0. Now I define my initial I to be 0, right? I said let I be 0. I said while I is less than 15. Now I will always 0 will always be less than 15. So if I for any reason run this code, it will not be adding 0, 0, 0 to this list till I run out of memory and maybe my system crashes or something. Okay, so it's always good to watch out for infinite loops. Okay, so how do I make this thing robust? I have to find a way of increasing I. Now, the way of increasing I is to put, these are the do I is equals to, okay, I plus 1. So now once I do this, it means that after this line, after it has appended the first I, which is 0, it's going to increase I by 1. So the next I will be 1. So it's going to check again. Is 1 less than 50? Yes, it's going to continue this loop. Continue, increase that I until it gets to 15. So once it gets to 15, you now check, is 15 less than 15? Definitely not. So since this condition is no longer true, it's going to break out of the loop. Okay, so it's going to stop appending I. And then I can now come here outside the loop, remember, and print my list. This time it is 2. So I run that, you can see it printed the same thing it printed here. Okay, I hope that makes sense. That way you said, can't we index it like we did to others? Can't we index it like we did to others? I didn't get that. Well, the idea of while loop is that you are not actually looping over something. You are just doing something until the condition is met. Okay, that's the idea of while loops. Okay, so for instance, say you're creating a game. You want someone to guess a number. I want you to guess a number maybe 5 times. So you put all your codes inside a while loop and you create a counter. So once that counter is equals to 5, you break out of the loop. Okay, I don't think you can do that with for loops, because for loop will just iterate over a list or iterate over an iterator. But in while loop will continue to run continuously. Most of the time they can do the same thing, right? And actually for loop is shorter to do things like it's looping over something. But while loop also has its place when you want to run something automatically, or you want to run something continuously until a condition is met. So really, you wouldn't do indexing like that. You're just create this condition can be anything. Okay, it can be anything. In fact, I can call this true. That's the interesting thing. Now, if I say something like while true, what will happen is that it will do this thing forever. Okay, it will do this thing forever. So how do I break out of this loop? I can now put an if statement. Okay, so after my increment, so while true means continue to do this forever. So it adds I was 0, it does that, it increase 1, it continues, adds that now I is 1, it adds 1 to the list, it continues, adds 1 again, now I is 2, it puts 2 to the list, and continues this forever. Now, how do I break out of this loop? So have flexibility to loop, you have to use an if statement because you want to put the condition. So if I want to put that statement, I'll say if I, okay, is equals to, or let me use less so it doesn't confuse you. So if is less than 15, okay, if this guy is less than 15, break out of this loop. Now, break is a keyword. I was planning to talk about break later, but I think it's a good time to talk about it. So break is just a keyword to break out of the loop on your own. Maybe you just want to create something and then you want it to break once any particular condition is met. Use the break statement. Okay, so once this guy sees this break statement, it's going to break out of the loop. So if I run this, print 0. Wait a minute, we shouldn't do that. Okay, I guess I should have put this here somewhere. Let me see. Okay, Gracious said he or she just ran an infinite loop. What you do is that you just have to stop your kernel. Okay, so what you do is you come here, all right, interrupt the kernel and stop it. So that's how you do it. So it can be very crazy if you run an infinite loop. So let me see how to fix this. Because if I actually run this without any of the stuff, it's going to be an infinite loop. Let me try it out if you guys don't believe me. So I'm going to just test and then I run. You can see it's an infinite loop. This asterisk means this code is loading. It's still running. Okay, that's the meaning of this asterisk here. And then, yeah, it can happen. You can see maybe your computer is running out of memory, and then it's telling you that you have overworked me. So that's why you have to be careful of any infinite loop. And for me, I can just stop this because this once I stop this, you can see it's going to just give me the error that I interrupted it. Okay. So that's an infinite. Um, that's an infinite. I'm trying to see how to fix this. It was less than 15. So immediately it got at the first instance of the indexing, it just broke out of the loop straight away because, of course, 0 was less than 15. So I should have put if it was greater than 15. Okay, that was a mistake I made. So if it's greater than 15, at that point, then it's going to break out of the loop, and that's why you can see that happen. Okay, so we have less than a minute, so guys, it's unfortunate, but we'll stop here. Tomorrow, I'm going to talk about a very interesting concept. I think we've talked about control flow and all, which is great. For loops, while loop, and if else statements. That's fantastic. So tomorrow, we are going to talk about object-oriented programming. Now, it's like a fundamental concept when it comes to programming because if you know it, it's going to help you a lot. And then once we finish that, we can now go to importing models. And once we are done with that, we are done with Python, and then we can now move into libraries like NumPy and Pandas, which are most of the things you would use when it comes to data science. So I'm hoping that you guys had a great time today. And then if you've got any question, unfortunately, I won't be able to take that question because I have less than a minute. But if you've got any question, please drop them on the group. Your fellow, your colleagues can answer you. And if they don't, I can answer you. You can also send me a personal message and I would answer you.